Welcome to the AI Coach by Anil Nathu.
Great to be here.
Today we're embarking on a deep dive into Claude Code. It's this tool that, well, it promises to really shake up how we build software. But the big question is it truly that, 10x coding partner we've all been dreaming of?
Or is it maybe another incredibly powerful tool that still needs quite a bit of human guidance?
Exactly. We're going to explore both sides. The magic, definitely, but also the crucial caveats you need to know about.
That's right. And to give you the most complete picture possible, we've pulled from a really diverse stack of sources. We didn't just look at the official docs.
Well, definitely no.
We've gone through practical guides, tons of real-world developer experiences shared on places like Reddit, and even some pretty cutting-edge research papers on AI governance.
Right, getting that full perspective.
Yeah, this holistic approach means we won't just tell you how to use Claude Code. We'll dig into why it works the way it does, what its actual real-world impact is looking like, and the really essential things to consider for using it responsibly.
Absolutely. Our mission today is to equip you, our listener, with the knowledge and, just as importantly, the actionable strategies to confidently start integrating Claude Code into your own projects.
Yeah, whether you're just tinkering, maybe building a simple game, or tackling much more complex software development tasks.
Or even if you're just trying to understand where this powerful AI fits into the bigger picture.
Exactly. We'll uncover some surprising capabilities, share practical guidance, and distill those crucial lessons learned from developers who've really been in the trenches with Claude Code.
Okay, let's unpack this. So let's start right at the beginning. When we talk about Claude Code, we really need to first understand the infrastructure underneath it all, the Claude API. What exactly is that, and why is it sort of the gateway for developers?
Yeah, that's the perfect place to start. Think of the Claude API as like a sophisticated bridge. It directly connects your own applications to Anthropic's incredibly powerful AI models. It's what allows your software to seamlessly send prompts, instructions, questions, whatever, to Claude, and then receive the AI's outputs right back where you need them.
So you could pipe that output anywhere.
Pretty much. I mean, you could take Claude's generated text and save it straight into a database. Or maybe display dynamic AI-powered content to your users in real time.
Oh, interesting.
Or even use Claude's responses to trigger more complex logic within your existing software. It basically turns Claude from, a standalone chatbot into a true programmatic powerhouse you can build with.
And what can this API actually do? What are the core capabilities that make it so flexible for developers?
Fundamentally, it offers two core capabilities that really stand out. The first one is text generation.
Right, the bread and butter.
Exactly. Claude can create anything from short, concise snippets of text to really elaborate multi-page documents. It can answer incredibly complex questions. It can summarize extensive reports, even generate creative content. But here's where it gets really interesting. Its massive context window. We're talking up to 200,000 tokens.
200,000? That sounds huge. What does that actually mean in practice? Like, how many words is that?
It's roughly equivalent to about 160,000 words. It's staggering.
160,000 words. That's mind-boggling. So what does that massive context window really mean for a developer? It sounds like more than just a bigger number.
Oh, it absolutely is. That 200,000 token window isn't just about processing more words. It fundamentally shifts what's even possible.
How so?
Well, imagine the friction it removes. Instead of constantly feeding Claude little snippets of your code or struggling to keep its quote-unquote memory of your project alive.
It's going to be really tedious.
Totally. You can effectively give it your entire code base, or at least very large chunks of it. This lets it spot architectural flaws that span multiple files, or refactor code across different modules, or understand a completely new project from end to end in a way smaller models just physically can't.
So get it to see the bigger picture.
Exactly. It's like giving Claude perfect short-term memory for your whole development environment. It can hold the whole project context in its mind at once, which is just a game changer for complex tasks.
That is a profound difference in how you can interact with an AI. Okay, so that's text generation with a massive context window. What's the second core capability?
The second is vision. So beyond just text, Claude has the ability to analyze images.
Analyze images. How does that work?
You can send it an image, maybe a screenshot of a user interface you're working on, or a complex system diagram, and then you can ask it questions about the content within that image. It can interpret visual data and respond in text.
Okay, so it can understand what's in the picture.
Precisely. But, and this is crucial to understand, there's a key limitation here. Claude cannot generate images itself.
Okay. No image creation, just analysis.
Right. It can only understand and process them. So think of it as an interpreter, not a creator, in the visual realm.
Got it. It's making sense of what it sees rather than dreaming up new visuals.
Yeah.
That clarifies a lot. Now, how does Anthropic charge for all this sophisticated processing power? Is it like a monthly subscription or?
No, the Claude API operates on a pay-as-you-go model. This is pretty common in the AI API world and actually offers a lot of flexibility.
How does that work? Per request?
Yeah, you're charged per request, and it's based on the number of tokens involved. Both your input, that's your prompt, and the output, which is Claude's response.
Okay.
It's worth noting, too, input tokens are generally less expensive than output tokens, and the overall cost can vary quite a bit depending on which specific Claude model you choose to use.
Right. There are different models.
Yeah, for example, the smaller, faster Haiku model is way more economical than the really powerful but pricier Opus model, so you can kind of tailor your usage to your budget and your project's needs.
That flexibility is definitely a plus, especially if you're just experimenting or getting started. Okay, now let's drill down into Claude Code itself. If the API is that integration layer, that bridge, what is Claude Code as an agentic assistant? What makes it different from just talking to Claude in a web chat?
That's a great distinction to make. While the API gives you that raw programmatic access, Claude Code is Anthropic's specialized AI-powered coding assistant. It's designed specifically to help developers write, analyze, and even run code.
Run code.
Yeah, within certain safety constraints, of course. What makes it unique is that it's an agentic coding tool.
Agentic. What does that mean in this context?
It means it doesn't just sit there passively waiting for your prompt. It operates directly within your terminal, your command line. And crucially, it's built to understand your entire code base, or at least have access to it.
Oh, okay.
So it's not just generating isolated snippets of code. It's actively interacting with your development environment, understanding file structures, reading files, and executing commands in a controlled way.
So it's less like a really smart text editor and maybe more like a junior developer working alongside you, actually seeing your project files?
That's a really good analogy, yeah. And it has a surprisingly broad range of practical capabilities for developers.
Like what?
Well, for instance, it really excels at editing and refactoring code. You can ask it to modify, optimize, or enhance existing code, and it gives you AI-powered suggestions.
That alone sounds incredibly useful for legacy code or just cleaning things up.
Totally. It's also incredibly adept at bug fixing. It can help identify and resolve errors, track down missing dependencies, and even spot performance bottlenecks. Think of it as an extra tireless pair of eyes on your code, spotting things you might miss.
That sounds incredibly helpful for getting unstuck or cleaning up messy code bases. Does it also help with understanding code you didn't write yourself? Like jumping into a new project?
Absolutely. That's another strong suit. It offers really strong code understanding capabilities. You can ask it detailed questions about your project's architecture, specific logic flows, or even complex dependencies within your code base.
Okay.
Beyond that, it can help with automated testing and linting. It can execute tests, help figure out why they're failing, and even run linting commands to improve code quality and consistency.
Linting, too. Nice.
And something that's truly impressive, highlighting that agentic nature, is its Git integration.
It integrates with Git. How?
Yeah, Claude Code can search through your Git history. It can help resolve tricky merge conflicts. It can create commits based on the changes it helped make, and even generate pull requests.
Whoa. Creating commits and PRs. That's pretty advanced.
It really highlights that it's not just a chatbot. It's designed to be an active participant in your actual version control workflow.
That level of integration sounds like it could be a massive time saver. Who typically benefits most from using Claude Code in their workflow? Who is this really built for?
Well, based on what developers are saying and the examples we've seen, it seems ideal for a few key roles. First, software developers who are really focused on consistently improving code quality and maintainability.
Makes sense.
Second, open source contributors, people who frequently need to jump into unfamiliar code bases, understand them quickly, and start contributing effectively. Claude Code can really accelerate that process.
I can see that being huge for open source.
And third, DevOps engineers, folks looking to automate tasks like parts of code review, enforcing standards, or running automated checks. It's designed to adapt to your specific coding style and project requirements, pretty much regardless of the scale.
Now, whenever we talk about a tool that can interact with your local system, maybe run commands, security immediately jumps to mind. How is Claude Code designed from a security perspective? What are the guardrails?
That's a critical question, yeah. And there's been some insightful security analysis on this. By design, Claude Code runs with your current user privileges. It doesn't try to escalate permissions.
Okay, that's important.
And its operations are typically scoped just to your current working directory, or CWD. It won't just go wandering around your file system.
So it stays in the project folder, mostly.
Mostly, yeah. And it's built to ask for your explicit user consent if it needs to access unfamiliar files outside that immediate scope or execute commands that haven't been pre-approved.
So it asks permission.
Yes. Its core security model relies on two main controls. CWD restriction, meaning file operations, are limited to that defined scope, preventing unauthorized access elsewhere. And second, pre-approved commands.
What does that mean? A whitelist.
Exactly. It's a strictly defined whitelist of safe, common operations like ls to list files, cat to display file contents, or echo to print text. Critically, it doesn't allow potentially dangerous commands like arm to remove files unless you go through some very explicit, often hard-to-miss user confirmation steps.
So it's reasonably sandboxed, but you still need to be mindful.
Precisely. While it's powerful, the aim is to keep its actions within clear, user-approved boundaries. But like any tool with system access, vigilance is always a good idea.
Right. Okay, so for those ready to roll up their sleeves and actually try this out, how do we get started with the Claude API, specifically using Python? What's step one?
The first step is quite straightforward.
Yeah.
Step one, create an Anthropic account. You just navigate to the Anthropic console, console.anthropic.com, and set up a developer account. That's your entry point.
Okay, account created. Now, how do you actually pay for the power you're about to unleash? To fund it somehow.
Right. Step two, add credits. This is essential to actually use the API beyond maybe some initial free tier, if they offer one. You'll head to settings in the console and then billing.
Okay.
Anthropic will ask for some basic info about how you plan to use the API, then you'll enter your payment details. You usually have flexibility here. You can choose a one-time payment to load up some credits or enable auto-reload.
Auto-reload, so it tops up automatically.
Yeah, it automatically adds funds when your balance drops below a certain amount you set. Keeps things running smoothly if you have ongoing usage.
And is it expensive to just try out?
Honestly, for tutorials and initial experimentation, the cost can be really minimal. Matthias 10T from Tilburg.ai mentioned it only cost him like 5 cents for some initial playing around. You might even get some free credits when you first sign up, which makes dipping your toes in very accessible.
That's great news for anyone just wanting to experiment without a big commitment. After credits, what's the most crucial piece of the puzzle to actually talk to Claude programmatically?
Step 3. Get a Claude API key. This is your secret credential. Still in the Settings tab in the console, you click API keys, then Create key. Give it a meaningful name like my Python project key or something.
Great.
And then this is absolutely critical. Copy that key to a safe, secure location immediately.
Immediately. Why the urgency?
Because you won't be able to view the full key again after you close that pop-up window. It's shown once for security reasons. So copy it, paste it somewhere safe, like a password manager, before you click away. Treat it like gold.
Gotcha. Don't lose it.
Exactly. API key security is paramount. Keep it strictly confidential. Sharing it is like giving someone your credit card for using the API. For any real production apps, you absolutely need to dive deep into Anthropic's full API security best practices documentation.
And speaking of security, just copy-pasting your API key directly into your Python code. That's a huge no-no, right? What's the proper way to handle it?
Oh, absolutely. Hard-coding keys is a massive vulnerability. That's why securing your key with environmental variables is pretty much a non-negotiable step. You never want that key showing up in your source code, especially if you might share it on GitHub or somewhere.
Right. So how do you set that up? Let's say for Mac or Linux first.
Okay, for macOS or Linux users, you'd open your terminal, then you type something like nano.zsrc or maybe .bash profile if you're using an older shell. That opens a configuration file in a text editor.
Okay.
You scroll to the bottom and add a new line. Export Claude API key, your API key. Make sure to replace your API key with your actual key, keeping the quotes.
Got it. Export variable name equals key in quotes.
Exactly. Then you save the file, usually CRL plus O in nano, then enter, then cdrl plus X to exit. And importantly, in that same terminal window, you need to run source.zsrc or source.bash profile to load that new variable into your current session.
Okay, so source makes it active immediately. And for Windows users, what's the equivalent process?
On Windows, it's a bit different, uses the graphical interface, but achieves the same thing. You'd right-click on this PC or my computer, select Properties, then go to Advanced System Settings and click the Environment Variables button.
Okay, typical Windows settings path.
Yeah. Under the System Variables section, click New. For the variable name, enter a Claude API key. For the variable value, paste in your actual API key. Click OK on all the windows to save it. You might need to restart your terminal or even your machine for it to take effect system-wide.
Got it. And how can you double-check it worked on either system?
Good question. You can verify it in your terminal. On Mac Linux, type echo Claude API key. On Windows, hit echo %lot API key %. If it prints your API key back to you, you've set it up correctly. This is a fundamental security practice, keeping that sensitive key out of your code.
Excellent. So environment setup, precious API key is secured. Now, how do we actually integrate Claude into our Python code and start making requests?
The integration itself is actually very straightforward, thanks to their official library. That's step 4. Install the Anthropic library. Just open your terminal and run pip install Anthropic. Simple as that.
Pip install Anthropic, got it.
Mm-hmm.
And then bringing it all together in your actual Python script.
Right. Step 5. Import required packages. In your Python file, you'll need to import OS that's crucial for accessing your environment variables securely. And you'll import Anthropic from the Anthropic library you just installed.
Okay, OS and Anthropic.
Then, step 6, initialize the Anthropic client. This is where you connect to the API. You do this by calling client Anthropic, apikeyos.environ.get, Claude.
os.environ.get. That's pulling the key from the environment variable we just set.
Exactly. This line is so important because it securely loads your API key without ever hard-coding it. This is key to leveraging the kind of secure development practices we talk about at AI Coach by Anil Nathu.
Perfect. And then the moment of truth, making your very first request to Claude. How do you structure that call?
Step 7, make your first request. You'll use the client.messages.create method. This is the main function you'll use to interact with Claude.
Okay, messages.create. What goes into that?
You need to specify a few key parameters. The model you want to use, for example, Claude 3 Haiku 2240307 for speed and lower cost, or maybe Claude 3.5 Sonnet for more powerful reasoning.
Got it. Choose your engine.
Yep. You also set max tokens. This controls the maximum length of Claude's response, and it directly impacts your cost, so you manage it carefully.
Right. Longer response, more tokens, more cost.
Exactly. And temperature. This is a fun one. It ranges from 0 for highly consistent, almost deterministic responses, up to 1 or even higher for more creative, random, and sometimes unexpected outputs.
So 0 for predictable, 1 for creative.
Pretty much. And of course, the most important part, the messages parameter. This is a list of dictionaries. Each dictionary represents a turn in the conversation.
A list of turns, like a chat history.
Precisely. Each dictionary needs a role, usually user, for your input or assistant, for Claude's previous responses if you're continuing a conversation, and the content of that message.
Okay, so if I just want to test it out with a simple prompt, like asking for a joke, how would that look?
Yeah, a common first request might look like this inside the messages list. Role, user, content. Hi there. Tell a good joke in the form of a question. Do not yet give the answer.
Okay, just one turn in the list from the user.
Right. You pass that list to client.messages.create, along with the model, max tokens, and temperature. Then you typically print the content part of the response object you get back. This basic example clearly demonstrates Claude's fundamental text generation capability and confirms your whole setup is working correctly.
Perfect. That seems like a solid foundation to build on.
Absolutely. From here, the possibilities really start to open up.
Okay, we've got the basics down, setup, secure API key, first request check. But where Claude truly shines and where that whole agentic nature really becomes apparent is in its more advanced capabilities. Let's talk about custom tools first, because this sounds like where the AI starts to actively interact with the real world, or at least your world, not just generate text.
Yeah, this is genuinely a powerful feature, and it's where Claude goes from being just a smart assistant to potentially a true collaborator. Custom tools allow Claude to, as you said, observe and interact with the real world by letting you define arbitrary Python functions that Claude can then intelligently decide to call.
So I write the function, and Claude can use it.
Exactly. Imagine telling Claude something like, check the current weather in Paris, or send an email summarizing this conversation to John. If you've provided the tools, the Python functions to do those things, Claude can figure out it needs to use your getWeather tool or your sendMail tool and generate the correct inputs for them.
Wow, that brings the external world, or at least external actions, right into Claude's reasoning loop.
That's exactly it. It bridges the gap between the AI's text processing and real-world actions or data retrieval.
That's incredible. How does this actually work under the hood? It sounds quite complex, more than just a simple API call.
It involves a few key steps, but it's quite elegant once you see it. First, you, the developer, define a standard Python function, let's say get weather location, or maybe save data to data, just regular Python code.
Okay, write the function I want Claude to be able to use.
Step 2, you need to convert this function into a JSON schema. This schema is essentially a blueprint, a description that Claude can understand. It details the function's name, what its purpose is, and crucially, the parameters it expects, like location for the weather function.
So it's like function documentation, but for the AI.
Exactly. It's how Claude understands what tools are available in its toolkit and how to use them, just like a human developer would read documentation or a function signature.
Okay, so I've defined my function, created the JSON schema describing it. What happens next? How do I tell Claude about it?
Third, you pass these schema objects to Claude using a specific tools parameter when you send your message via client.messages.create. You basically hand Claude the list of tools it can potentially use for this specific request.
All right, so Claude gets my prompt and the list of available tools. What does it do then?
When Claude receives your prompt and these tool definitions, it reasons about whether it needs to use one of them to fulfill your request. If it decides, yes, I need the get weather tool for this, its response won't be a direct text answer.
Oh, what does it send back then?
Instead, it will return a special JSON object. This object contains the name of the tool it wants to use, for example, get weather, and the input parameters it wants to send to that tool, e.g., location, Paris.
So it tells me what it wants to do, but it doesn't actually do it itself. Claude doesn't execute my Python function, right?
Precisely. That's a critical point. Claude doesn't have the ability or the permission to directly execute arbitrary code in your environment. That's your job as the developer orchestrating this.
Okay, so the responsibility of running the tool is still on my side. What do I do with Claude's response then?
Right. So in your Python code, you check Claude's response. If it indicates a tool use, you parse out the tool name and the arguments. Then you call your actual Python function, like getWeather, Paris, with those arguments.
Okay, I run my function with the inputs Claude suggested. Then what?
Here's the really clever part. You take the output, the result of your function, say the weather data string, or maybe a confirmation message like email sent successfully, and you send that output back to Claude.
Send it back. How?
You make another call to client.messages.create, adding both Claude's previous tool use request and a new message with the whole tool result containing the output of your function to the conversation history.
Ah, so you're continuing the conversation, feeding the tool's result back into the context.
Exactly. This creates this powerful, iterative, recursive loop. Claude asks to use a tool, you run it, you tell Claude the result, and then Claude can use that real-world information to continue its reasoning, maybe use another tool, or finally generate the text response you were originally looking for.
That is genuinely powerful. It's like giving Claude senses and hands to interact with things beyond just text. Let's look at a concrete example. That bootleg artifacts feature case study you mentioned, that seems like a perfect illustration of how this recursive loop works to give Claude a sort of memory for a project.
It's a brilliant, really practical use case that perfectly showcases the power of custom tools. Okay, so the situation was this. At the time this developer, Pixagami, was working on this, Claude's web UI had this nice artifacts window. It let you store code snippets, notes, text files, essentially giving Claude a persistent workspace for your project.
Right, I see that. Very useful.
Yeah, but that feature wasn't available directly via the API yet. So the problem was, how do we replicate that kind of project persistence, that workspace memory for API users?
Okay, how do they solve it with tools?
The ingenious solution was to create custom Python functions that mimic file operations. They created functions like save artifact file path content, load artifact file path, and list artifacts directory path.
Ah, so tools that let Claude interact with the local file system, simulating that artifacts window.
Exactly. These functions acted as Claude's interface to a designated local folder acting as the artifact space.
And the interesting twist here you mentioned was that the author used Claude itself to generate the JSON schemas for these custom file system tools. That's very meta.
Absolutely. It's a fantastic example of meta-prompting, having the AI assist in setting up its own capabilities. A truly meta-level interaction showing how helpful Claude can be even in its own integration process.
Okay, so they set up these file system tools. How did that play out in practice?
Well, once these tools were defined and made available to Claude in the API calls, their real-world power became immediately clear. For instance, you could then prompt Claude, write me a Python program that can add two numbers together, and save that program to our artifacts folder as add.py.
And Claude would.
Claude would analyze that request, intelligently realize it needed to save a file, choose to use the custom save artifact tool you provided, and generate the correct arguments. File path, add.py, content.python code. Your code would then execute that function, saving the file locally.
So it's not just writing the code, it's actually organizing it within a defined file structure that it can then interact with. And remember later using the other tools like load artifact. That opens up so many possibilities for managing complex projects over multiple interactions.
Exactly. And you can take it even further, really demonstrating that recursive loop we talked about. You could follow up with a prompt like, okay, now run a simple happy case unit test using PyTest for every Python file currently in this artifacts folder.
And how would Claude handle that multi-step request?
It would first respond by indicating it needs to use your list artifacts tool to see what files are actually in your artifacts folder. Your code runs that, gets the list, say add.py, multiply.py, and sends that list back to Claude.
Okay, so now it knows the files.
Right. Then Claude would process each file name. For add.py, it would generate the PyTest unit test code. Then it would respond again, this time indicating it wants to use your save artifact tool to save this new test code, maybe as test.add.py, your code saves it. Then it would do the same for multiply.py.
Wow. So it's listing, generating, saving, all orchestrated through these custom tools.
Precisely. And the author confirmed that the generated tests actually worked when run with PyTest. This perfectly demonstrates Claude's ability to create, analyze, and manage code files through custom tools, giving it that persistent memory and enabling truly dynamic multi-step coding workflows that were previously impossible via the API alone.
That's a fantastic example of extending Claude's reach. Let's shift gears slightly to another advanced API usage. Vision, the image processing capability. How does Claude interact with visual data via the API?
This capability allows you to send images directly via the API and include them as part of your prompt. It unlocks some really powerful analysis use cases.
Like what sort of things?
Well, we've seen previews of Claude's web UI doing things like replicating a web page's structure just from a screenshot, or you could feed it complex diagrams and ask it to explain them. It's also surprisingly effective at analyzing data embedded within charts and graphs, turning that visual information into structured text or insights.
That AWS Lambda pricing table case study really brought this home. Can you walk us through how that worked and what kind of insights Claude could pull from just looking at a picture of a table?
Sure. The process involved, first, loading a local image file in this case. It was literally a screenshot of an AWS Lambda pricing table web page. Then encoding that image data into base64 format, which is a standard way to represent binary data as text.
Okay, load image, encode it.
Then you send that encoded image data along with a text prompt to Claude via the API. The example prompt used was something quite specific, like, model the usage cost of AWS Lambda under the following circumstances based on the attached pricing table, followed by details of usage scenarios.
So you give it the picture and instructions on how to use the information in it.
Exactly.
Yeah.
The goal was to have Claude extract the pricing rules from the image and then apply them based on the text prompt.
And the outcome was pretty insightful, wasn't it? Claude could actually read the numbers and rules from the image.
Indeed, it could. Claude was able to interpret the image's pricing information, the different tiers, costs per request, cost per GB second, etc., and combine it with the text prompt to calculate estimated cost projections for different usage scenarios, like for 1,000 users versus 10,000 users.
That's impressive. It's actually doing calculations based on visual data.
Yeah. Now, the author rightly noted that you definitely want human verification for absolute financial accuracy before making decisions based on it.
Of course, always double-check the numbers.
Right. But it powerfully showcases Claude's ability to extract and apply complex numerical and rule-based information directly from visual data. This opens up really exciting possibilities for integrating AI into workflows that deal with diverse data types, where you might have screenshots, scanned documents, diagrams, maybe even handwritten notes that need to be understood and acted upon.
It's clear the API offers immense flexibility then for both sophisticated code generation with tools and interpreting visual data. Now, let's talk specifically about how Claude Code, the tool itself, is used for day-to-day software development workflows directly in the terminal. Things like refactoring, documentation, and even debugging, as detailed by folks at DataCamp.
Right. So once you're set up and authenticated, which usually involves a simple npm install -g at Anthropic, a Claude code, then CID into your project directory and just type in Claude to start the agent.
Okay, so it runs as a command line tool.
Yeah, it works directly within your terminal. Developers often use it as a powerful co-pilot for common tasks. A perfect illustration comes from a case study Ashi Dutt wrote about, focusing on improving the Supabase Python SDK, specifically a file named client.py.
Okay, how does it help with refactoring existing code in that context? Is it just suggesting minor tweaks, or can it do more substantial reorganization?
It can be quite substantial. By providing a relatively high-level prompt like refactor the code in the client.py file located in the Supabase folder, Claude can propose significant enhancements to readability and maintainability.
What kind of changes did it suggest for that file?
For that specific client.py file, it took actions like automatically reorganizing the import statements, intelligently grouping related sections of code together, renaming some imports for better clarity, identifying and removing redundant code, and even adding helpful section comments to break up long blocks.
And the developer's role is just to review and accept.
Pretty much. The beauty is that Claude presents these proposed changes, often as a diff, and you just review and approve them. It gives you complete control while automating a lot of the tedious refactoring work. It's like having an experienced peer instantly review your code and suggest improvements.
That sounds like a huge time saver, especially on larger files. What about documentation? That's something that often gets neglected or becomes inconsistent in projects.
Claude is apparently excellent for generating and standardizing documentation. A straightforward prompt like document the client.py code by adding comments to improve understanding can lead to really good results.
Like what kind of documentation? Doc strings, inline comments.
All the above. It can generate clear module-level doc strings explaining the file's purpose, add detailed section comments to explain logical blocks, and insert precise inline comments to describe specific variables or complex lines of code.
That's useful. Can it check against existing standards?
Yes, you can even prompt it further, like check if the documentation in this file follows our project documentation standards, assuming you've provided those standards elsewhere. This is invaluable for maintaining consistent code quality and knowledge sharing across a team or an open source project. It ensures critical knowledge about the code base is captured and maintained without all the manual drudgery.
Okay, refactoring, documentation. What about every developer's favorite pastime? Debugging. How does Claude Code assist there? Can it actually fix errors or just point them out?
It definitely helps streamline debugging. It can analyze error messages and propose concrete solutions. The typical workflow seems to be you encounter an error, you share the full error message directly with Claude in the terminal interface, ask for its recommendations, and then apply and verify the suggested fixes.
Can you give an example?
Sure. Say you encounter a seemingly cryptic Python error, like import go true, errors is not resolved by your type checker. Claude might analyze this and suggest adding a hashtag type. Ignore comment on that line to suppress the specific type checking warning if it understands the known issue or dynamic import.
Okay, so a targeted fix.
Or it might identify a deeper issue, maybe inconsistency in how different error categories are being handled throughout the file, and propose a more systematic fix to ensure consistent error categorization.
So it can propose both tactical workarounds and more strategic fixes.
Exactly. Now, it's worth noting that some of these more advanced debugging features might still be in preview or evolving, so you always need to verify the fix. But it clearly shows Claude's ability to diagnose problems and propose actionable solutions, potentially cutting down significantly on frustrating debugging time.
This really paints a picture of Claude Code as a powerful co-pilot for daily development tasks. It's moving way beyond just simple code generation to truly assisting with the entire software development lifecycle.
It really is. And the AI Coach by Anil Nathu is all about helping you understand how to build these kinds of advanced integrations and workflows, really accelerating your journey from a rough concept to robust, deployable code.
All right, so we've covered the what the API foundation and the how, the practical applications and development workflows. Now let's dive into the how well and maybe the what to watch out for. Because getting the absolute most out of any large language model, especially for something as complex and precise as coding, really means you need to become skilled in effective prompting.
Oh, it truly is the art and science of working effectively with these LLMs. You can't just toss vague requests at them and expect miracles, especially for code.
So what are some key techniques?
Well, one fascinating approach, something that comes up a lot in developer discussions and on platforms like Reddit, is the power of meta-prompting.
Meta-prompting, what's that?
It's basically having Claude itself act as an expert prompt engineer to refine your initial, maybe vague input.
You mean you ask Claude to help you write a better prompt for Claude?
Exactly. Imagine you start with a fuzzy idea. You feed that fuzzy idea to a specialized Claude project you've set up. Maybe you called it Prompt Rewriter. You've given this Claude instance detailed instructions. Analyze the user's input, craft a clearer, more concise, more specific prompt based on it, ensure all necessary context is included, and even ask the user clarifying questions if the initial input is too ambiguous.
Okay.
Then, this Prompt Rewriter Claude presents the refined, much better prompt back to you, often in a nice code block, and maybe even explains why it made the changes it did.
That's incredibly clever. It's like turning the LLM inward to improve its own inputs.
It's brilliant, isn't it? It really showcases how these models can be used recursively to improve their own performance and, ultimately, your efficiency.
That's a great advanced tip. Are there any other, maybe more direct techniques for structuring prompts that Anthropic themselves recommend for better results?
Yes, they do. Anthropic officially recommends using XML tags for structure within your prompts.
XML tags, like task and task.
Exactly. Using tags like task, context, file content, role, things like that. This isn't just for making it look organized. Apparently, it significantly helps Claude parse your prompt more accurately.
How does that help?
Think of it like giving Claude a well-labeled filing cabinet with clear sections instead of just handing it a messy pile of papers. It makes your intent more explicit, helps Claude zero in on the different pieces of information you're providing, and as a bonus, it can sometimes even use fewer input tokens because the structure is clearer, which directly impacts your API costs.
That's a really practical tip that affects both clarity and cost. Good to know. And of course, the classic advice for any AI interaction. Be specific, right? What does specific really look like in a coding context with Claude?
Absolutely. Specificity is king. Always. The quality of Claude's code output is heavily, heavily dependent on the clarity and detail in your prompts.
So give me an example. Vague versus specific.
Okay, a poor, vague prompt might simply be, add tests for foo.py.
Right, that leaves a lot open to interpretation.
Exactly. What kind of tests? Unit tests, integration tests. What scenarios should they cover? Should it use mocks? A good specific prompt based on advice from developers sharing their experiences would be something like, write a new unit test case for the process payment function in foo.py. Specifically, cover the edge case where the user's credit card has expired. Please ensure this test avoids using mocks and interacts with the actual test database.
Much clearer. Specifies the type of test, the function, the exact scenario, and even constraints like avoiding mocks.
Precisely. The more context, constraints, examples, and desired outcomes you provide, the better Claude can understand exactly what you need and execute your request accurately, which means fewer rounds of back-and-forth corrections.
Makes sense. Beyond crafting individual prompts, what about overall workflow strategies when you're tackling larger coding projects with Claude? This seems to be where many users run into significant hurdles. It's one thing to generate a single function, but quite another to manage an entire evolving code base.
This is a crucial area, yeah, where user experience and strategy make a huge difference. A really common piece of advice from experienced developers on Reddit who use Claude extensively is this. Treat Claude like a human developer joining your team.
Treat it like a human. How so?
It means providing Claude with the same level of context, background, and documentation you'd give to a human teammate who's new to the project.
So not just code, but project context.
Exactly. This includes standard project files like a good readme.md explaining the project's purpose and setup, maybe a contribution.md outlining how to contribute, style guides, etc., a usage.md explaining how to run or use the software, and especially a changelog.md to track changes and project history.
Why are those files so helpful for Claude?
Because these documents, usually written in Markdown, which Claude understands very well, simulate the kind of development environment and project information Claude was likely trained on. Giving it this context helps it understand the project's goals, constraints, history, and conventions, leading to much more relevant and consistent code generation. It's like giving it the project brief.
So instead of just pasting a single file and asking for changes, you're essentially giving it a comprehensive project onboarding package.
Precisely. Another absolutely vital strategy is modular and iterative development. Don't expect Claude to write an entire complex application in one single prompt. Even with that huge 200K token window, it's just not realistic or effective for complex tasks.
So break it down.
Yes, break tasks down into smaller, manageable modules, functions, or features. Generate a small piece of code first. Then, crucially, immediately test it in your actual development environment.
Test early, test often.
Exactly. If you hit errors or unexpected behavior, provide that feedback directly back to Claude, often just by copy-pasting the error message and the relevant code snippet right back into the conversation. Then ask Claude to refine it or add the next small feature based on that feedback.
So it's a continuous conversation, a feedback loop.
Absolutely. This iterative feedback loop is crucial for maintaining quality, managing context effectively, preventing the model from forgetting earlier parts, and stopping Claude from going off the rails on larger, more complex tasks. It's about having a dialogue, not issuing a single command.
That makes a lot of sense, building complex things step by step with checks along the way. What about a more upfront design approach? Can Claude help with planning before diving into writing the actual code?
Yes, definitely. Some users actually advocate for a style reminiscent of big design upfront, BDUF, even when working with AI.
Really? How would that work?
You could use Claude in an initial phase to help you brainstorm and build out a comprehensive design document first. This document might outline the overall architecture, data flows, key components, API specifications, etc.
Okay, get the blueprint sorted first.
Right. Once you're reasonably satisfied with that design document, you can add it as an artifact or context file to your Claude project. Then you can use a separate chat session, feeding it that design doc and maybe the current state of the code base, and ask Claude to analyze it. Based on that analysis, you create new, focused chat sessions specifically to implement individual features or components outlined in the design, starting perhaps with generating the basic scaffolding.
So the design doc acts as a constant reference point to keep Claude focused during implementation.
Exactly. It provides a clear guiding blueprint and helps keep its focus tight and aligned with the overall plan during those implementation phases.
Can you even incorporate more formal development methodologies like test-driven development with Claude? That seems like it would require a lot of careful orchestration.
It does require careful orchestration, but users report it's absolutely possible and quite effective. You can guide Claude through a test-driven development, TDD, workflow.
How would you do that? What are the steps?
Okay, step one. You tell Claude to write the test for a specific piece of functionality, but, and this is key, explicitly instruct it not to write the implementation code yet, just the tests. Then you ask Claude to run those tests, using its command execution ability carefully, and confirm that they fail as expected in TDD.
Red phase. Got it. Then what?
Once you're satisfied with the failing test, you might ask Claude to commit just the test to version control, using its Git integration. Step 3. Then you instruct Claude to write the minimal implementation code required to make those specific tests pass. You iterate on this, run tests, write code, run tests until all the tests pass, the green phase.
Okay, red, green. What about refactor?
You could even add a refactor step, asking Claude to clean up the code now that tests are passing. And you can even prompt it to double-check that the implementation isn't overfitting specifically to the test you wrote, ensuring it's a robust solution. It requires careful prompting, but it enforces good TDD discipline.
That's fascinating. And for UI/UX development, you mentioned the vision capability. Can Claude help turn visual designs, like mockups, directly into code?
Yes, this is another incredibly powerful application, especially for front-end work. For UI/UX, you can provide Claude with a visual mock. You can do this either by copying and pasting an image directly into the prompt if the interface supports it, or by providing a file path to an image file.
Okay, give it the picture of the design.
Right. Then you ask Claude to implement that design in code, maybe specifying the target framework like React, Vue, or just HTML, CSS.
And it just generates the code.
It generates the code, but the cool part is the iteration. Claude Code, running in the terminal, can sometimes even be prompted to take a screenshot of the rendered result of the code it just generated, using appropriate tools or commands you might need to set up. You can then compare that screenshot to your original mock, provide feedback, the button's too large, the spacing is wrong here, and have Claude iterate on the code until the visual output closely matches your intended design.
Wow, that iterative visual feedback loop sounds extremely powerful for front-end development. One last practical workflow tip. How do you help Claude keep track of the overall project structure,
Yeah.
especially in larger projects with many files and nested directories? Does it just magically know?
It doesn't magically know, and that can lead to confusion or errors if it tries to reference files incorrectly. A simple but incredibly effective tip, often shared by developers, is to use a standard command line tool like tree, you might need to install it, to print your project's folder structure.
Tree just lists out all the files and folders nicely indented, right?
Exactly. You run tree in your project root, capture that output, and then you can either add that output as a file, projectstructure.txt, to your Claude project's context, or even paste it directly into the prompt when relevant.
And that helps how?
This way, Claude gets a clear map of your entire code base layout. It understands the file paths, where things are located relative to each other, and can reference files much more accurately without you having to manually type out full paths every single time. It basically gives Claude a complete mental map of your project's geography.
That's a clever, simple trick.
Hmm.
Okay, this all sounds incredibly powerful, almost like coding magic at times. But let's be realistic, nothing is perfect. What are some of the common challenges, limitations, or maybe just frustrations that users have encountered when working extensively with Claude Code?
Right. While it is truly powerful, it's definitely not a flawless, hands-off solution. You need to go in with realistic expectations. A very common frustration voiced by many users in online forums relates to code management and redundancies.
What does that mean exactly?
Developers often find that the code Claude generates, especially in longer or more complex projects built over many interactions, can sometimes suffer from, let's say, less than ideal architecture. Poor compartmentalization, weird redundancies where the same logic appears in multiple places, unused functions left hanging around, or sometimes code just ending up in strange illogical file locations.
So it generates working code, maybe, but it might not be the cleanest or best organized.
Exactly. This often means you, the human developer, still need to perform significant manual combing, reviewing, and refactoring to ensure the final code base is clean, maintainable, and follows good architectural principles. It's not always going to produce beautifully elegant code on the first try, especially for complex systems.
So expect to do some cleanup.
Yeah.
What about practical limitations like those API token costs we discussed earlier? Does that become a real barrier in practice?
Yes, message limits and token costs can absolutely be a major hurdle, especially for more intensive use. Users frequently report running out of their allotted tokens or hitting context window limits surprisingly quickly when working on complex tasks that require a lot of back and forth, large file inputs, or deep analysis.
So you can burn through credits fast if you're not careful.
Definitely. This is why some developers adopt strategies like using other, potentially cheaper or free, LLMs like certain versions of ChatGPT for simpler problems, initial brainstorming, or generating boilerplate code just to conserve their more expensive Claude tokens for the really hard stuff where its advanced capabilities shine. It becomes a real balancing act between capability and cost.
That makes sense. And the quality of the generated code itself, should one expect perfection, or is it more like a starting point that needs work?
Definitely do not expect perfection. A very common sentiment among experienced users, almost a mantra, is to expect imperfect code. Assume Claude's output will be somewhere in the range of 60–90% correct on average.
60 to 90%.
Yeah.
So pretty good, but rarely perfect.
Right. It nearly always requires some level of refinement. This might involve you editing the code directly, or more often, providing clearer, more specific, iterative prompts for Claude to rewrite or fix the issues itself. Think of its output as a very good first draft, maybe even a second draft sometimes, but still a draft that needs your review and polish.
This really brings us back to the crucial point of human oversight. It sounds like Claude Code is not a set-it-and-forget-it tool at all then. It seems like it's a powerful assistant, but fundamentally still an assistant that needs guidance.
Absolutely not set it and forget it. The need for human oversight is paramount. While one user on Reddit reported Claude doing 99% of the coding for a complex open-source tool they built,
99% sounds amazing.
it does, but they also noted it took them over 500 iterations over 3 months to get there. And crucially, they had to learn to ignore a lot of its suggestions and use my own experience and intuition.
Ah, okay. So the human expertise was still absolutely critical in guiding those 500 iterations.
Exactly. This isn't a codeless solution where you just type vague ideas and get perfect software. You, the developer, still need to deeply understand the underlying technology, possess strong problem-solving skills, know what good code looks like, and guide Claude effectively. If you don't understand the code yourself, you won't be able to effectively steer Claude, debug its inevitable imperfections, or judge the quality of its output. In a way, it forces you to become a better specifier, a better tester, and a better architect. It enhances your skills, it doesn't replace them.
That's a really important perspective. It's a collaborator, not a replacement. So zooming out a bit, how does Claude Code stack up against other major AI models in the broader AI landscape? Peter Yang did a head-to-head comparison recently that shed some light on this. What were his findings?
Yeah, Peter Yang's tests revealed some pretty compelling results, especially regarding coding. For sheer coding prowess, particularly on complex, self-contained tasks, Claude 4, specifically the Opus model at the time, though Sonnet 3.5 is very strong now too, emerged as the best in his tests.
Better than competitors. How so?
He noted, quite strikingly, that it was able to build a gorgeous, full-featured Tetris game and even a playable level 1 of Super Mario starting from scratch after just 10-15 minutes of iterative prompting.
Wow, building playable games that quickly.
Yeah. And he reported that in those specific challenging coding tests, neither ChatGPT, presumably GPT-4, nor Gemini, likely 1.5 Pro at the time, came close to achieving that level of functional complexity and polish in the same time frame. That's a powerful testament to its capabilities for complex software generation when guided well.
That's a strong endorsement for its raw coding capabilities.
Uh-huh.
But there's always a trade-off, isn't there? Particularly with performance comes cost.
There usually is, and Peter Yang points out the catch. The high-end Claude models, like Opus or even Sonnet 3.5, can, in some usage patterns, cost significantly more. He estimated maybe 20 times more than something like Gemini 1.5 Flash, which is a Google's speed-cost optimized model.
20 times more. That's a huge difference.
It can be, yeah. So if cost versus quality is your absolute primary concern, especially if you're embedding AI into a high-volume product or you're just starting out on a tight budget, then a model like Gemini Flash might be the more cost-effective choice, even if it's slightly less capable on the absolute hardest tasks. It really becomes a strategic decision based on your specific use case and budget constraints.
And how do these different AI labs seem to be strategically positioning their models in the broader AI market? Are they all just aiming for the same general AI assistant goal?
It seems like they have increasingly distinct ambitions, or at least focus areas. OpenAI, with ChatGPT's conversational strength, its improving memory features, and broad plug-in ecosystem, seems to be really aiming to be your go-to personal AI assistant for a vast range of tasks, including coding, but not limited to it.
Okay, the generalist.
Right. Google's Gemini is, as Yang put it, rapidly waking up. They're pushing hard with very cost-effective models like Flash, really strong multimodal capabilities, handling text, image, audio, video, and leveraging Google's massive reach and data integration capabilities. They seem positioned for broad embedding into diverse products and services.
Makes sense for Google and Claude.
Claude, by contrast, appears very deliberately positioned to, quote, own coding for enterprise.
Own coding for enterprise. That's a bold claim.
It is, but look at the signals. Anthropic's first major AI conference was entirely dedicated to coding and developers. They are continuously rolling out improvements specifically to Claude Code, the agentic tool. Their messaging is very developer-centric. They seem laser-focused on becoming the go-to AI partner for serious, professional software development teams and large organizations.
Interesting strategic positioning. Now, despite all the challenges we discussed, the need for iteration, the cost, the imperfect code, there seems to be an undeniable magic to Claude Code when it's used effectively, particularly in how much it can accelerate development. Can you give us a sense of that magic in action?
This is where, despite the caveats, the true transformative power comes through, and it can be genuinely staggering for developer productivity. One Reddit user, username backgrounddig441, shared a really compelling experience. They built an open-source CLI coding tool, actually a tool to help use Claude for coding called Dravid.
Okay, a tool built with Claude, for Claude.
Exactly. And they reported completing the initial version of this non-trivial tool in just 4 to 5 days using Claude heavily, particularly leveraging its project context capabilities. This was a task they estimated, based on their own experience, would normally have taken them 30-60 days of traditional development work.
Compressing potentially 2 months of work into less than a week.
That's what they reported. Think about that level of acceleration. It fundamentally changes project timelines and what's feasible for small teams or even individual developers. The Dravid tool itself was even designed with the core assumption that Claude is eventually right, allowing it to recursively monitor its own generated code, detect errors, and attempt to fix them, often without needing constant user clarification. It was pushing the boundaries of autonomous development assistance.
That's a staggering acceleration. It sounds almost too good to be true, but it highlights the potential. Are other users also pushing these boundaries, maybe combining Claude with other tools or frameworks?
Oh, absolutely. The field is moving incredibly fast, and developers are constantly experimenting. Some users are reporting success combining Claude with other LLMs, maybe using Gemini for its large context window to ingest documentation, or DeepSeek Coder for specific code generation strengths, and orchestrating these different models using advanced agent frameworks like Crew AI or Present AI.
So creating multi-agent systems.
Essentially, yeah. Using frameworks that allow for more robust context management across different models and breaking down complex tasks into subtasks handled by specialized AI agents. This further amplifies the potential for accelerating development, moving towards a future where AI handles increasingly complex, interconnected parts of the software lifecycle.
It's an exciting, if slightly daunting, future.
It really is. And the AI Coach by Anil Nathu is all about helping you navigate this rapidly changing landscape, helping you harness this sometimes magical acceleration responsibly, understanding both its immense power and its current limitations and risks.
Okay, moving from the very practical applications and the nitty-gritty challenges of using Claude Code, it feels critical now to step back and consider the broader implications. These tools are incredibly powerful, and that brings us to the vital topic of AI governance and responsible development. Why should a developer, maybe head down coding on a deadline, really pause and care about this governance stuff?
It's becoming increasingly important, honestly, for everyone involved in building with AI, not just thinking about AI, to understand this context. As AI systems like Claude become more and more prevalent, more influential in society.
Right, they're not just lab experiments anymore.
Exactly. They're being integrated into everything from complex scientific computation and report generation, all the way to potentially influencing hiring decisions, shaping financial advice, and even driving mass communication through tools like chatbots and summarization. The need for effective AI governance and accountability becomes absolutely paramount.
And Claude is playing a big role in this integration, isn't it?
Yeah,
Through partnerships.
it is. Anthropic, the company behind Claude, has forged some really significant partnerships with major global companies, names like Scale AI, Zoom, Boston Consulting Group, AWS, Accenture, SK Telecom in Korea.
Wow, that's a wide reach.
It is. And this amplifies Claude's impact on individuals, often in ways people aren't even directly aware of. You might be interacting with a customer service bot powered by Claude or getting insights from a report generated by Claude without ever knowing it. So understanding the guardrails, the ethical considerations, isn't just an academic exercise for policymakers. It's becoming fundamental for responsible developers and businesses using these tools.
That's a key point. The often invisible influence of AI weaving into so many systems. So when we talk about AI governance, what exactly does that mean in practical terms? What are we trying to govern?
At its heart, AI governance is about putting sensible guardrails on incredibly powerful technology. It's the whole ecosystem of rules, policies, best practices, and technical mechanisms we design to make sure these increasingly smart systems are developed, deployed, and used responsibly.
So it's about safety and ethics.
Safety, ethics, fairness, transparency, accountability, all of those things. It's about safeguarding against potential harms, unintended consequences, biases, and misuse. Think of it as trying to build the ethical operating system for AI, establishing trust, and ensuring these systems are designed and used in ways that benefit humanity.
Now, Anthropic has a specific, quite unique approach to embedding safety and ethics directly into its AI model, something they call constitutional AI. Can you unpack that for us? How does it attempt to build that ethical operating system right into Claude?
Yeah, Anthropic employs this framework called constitutional AI, and it's their primary mechanism for attempting to hardwire kind of moral compass directly into Claude. The core idea is to align Claude's outputs with a predefined set of ethical principles and values of constitution, prioritizing safety and ethical considerations right from the model's core training process.
So it's not just a filter slapped on at the end. It's baked in.
Exactly. It's designed to be integrated deeply into the model's training itself, not just a post-hoc refusal mechanism, though it has that too.
How does that training process actually work? It sounds more sophisticated than just feeding it a list of rules like don't be evil.
It is quite innovative and involves two main stages. First, there's a supervised learning SL stage. In this phase, the model is initially trained, but then it's specifically trained to critique and revise its own potentially harmful or unethical responses through a process of iterative self-critique and fine-tuning.
So it learns to judge its own answers against the Constitution.
Kind of, yeah. It's guided by those constitutional principles, things like being helpful, harmless, honest, adhering to certain ethical guidelines. It learns to identify problematic outputs and generate better, safer alternatives based on the Constitution.
Okay, that's the supervised stage. What's the second stage?
Then there's a reinforcement learning RL stage. This is where things get really interesting. Typically, RL for language models relies heavily on human feedback, humans ranking different model responses. Anthropic's approach here, called RL from AI feedback, RLAIF, uses AI-generated feedback instead.
AI feedback. How does that work?
Another AI model, it's self-trained on the Constitution, evaluates pairs of Claude's responses, and picks the one that better adheres to the constitutional principles. This AI-generated preference data is then used to further fine-tune Claude using reinforcement learning. This unique approach has been shown, according to Anthropic, to produce models that are not only more helpful, but also significantly more harmless and less likely to generate toxic or biased content, and it scales much better than relying solely on human feedback.
Fascinating. Using AI to help train ethical AI, where do these guiding principles, this constitution, actually come from? Is it just something Anthropic's ethics team dreamed up?
They've drawn these principles from surprisingly diverse sources, attempting to create a broad ethical foundation, not just based on their internal thinking. They list sources like the UN Declaration of Human Rights, concepts from Apple's terms of service regarding privacy and data use, research-backed safety principles like those developed for DeepMind's Sparrow model, and importantly, they've also tried to incorporate values that encourage non-Western perspectives to avoid purely US Eurocentric biases.
That's quite a mix. I remember reading about an interesting experiment where Anthropic actually involved the public in drafting a constitution. What did that reveal? Did the public come up with different priorities?
Yes, that was a really interesting project back in October 2023. Anthropic partnered with the Collective Intelligence Project and ran a public input process involving around 1,000 participants, primarily from the US, to collaboratively draft an AI constitution.
And how did the public's version compare to Anthropic's internal one?
What's fascinating is that while there was significant overlap, maybe around 50% similarity in the core ideas, the public version put a notably stronger emphasis on principles like objectivity, impartiality, and accessibility. It also tended to focus more on promoting desired positive behaviors rather than just specifying undesired negative behaviors to avoid.
Interesting difference in focus.
Right.
Did it actually make a difference in the AI's behavior?
Apparently, yes. Anthropic reported that the Claude model variant trained using this publicly drafted constitution actually showed measurably lower bias scores across 9 different social dimensions they tested, with particularly noticeable improvements regarding disability status and physical appearance biases.
Wow. That's concrete evidence that diverse public input can actually lead to quantifiably more equitable AI.
It really highlights the potential value and perhaps the necessity of broader public participation in shaping the ethical alignment of these powerful systems.
That's a truly thought-provoking approach to ethical AI. However, despite constitutional AI's intentions in these positive steps, there are still identified threats, issues, and critiques surrounding Claude. What are some of the key concerns that researchers, ethicists, and even users are still pointing out?
Right. Even with constitutional AI, it's not a perfect shield, and critical analysis continues. One significant area of ongoing concern revolves around a perceived lack of transparency, particularly in privacy policies.
Privacy policies, what's the issue there?
Critics argue that Anthropic's policies, while detailed, don't always sufficiently or clearly disclose the specifics of how personal data, potentially, including things like browser information, mobile network details, IP addresses, unique identifiers might be collected and used for model training or improvement. The language can be complex, using legal or technical jargon, making it difficult for average users or even developers integrating the API to make fully informed decisions about their data or their users' data. Stanford's Foundation Model Transparency Index back in 2023, for instance, gave Claude 2 a relatively low score compared to some others at the time.
So the data handling aspect could be clear, which directly impacts a developer's responsibility when building apps on top of the API, especially if those apps handle sensitive user info.
Exactly. Developers need to be acutely aware of the potential data flows and the policy implications. Another persistent challenge, common to all large language models, is the potential for hallucinations.
Right, the AI making things up confidently. Is that still an issue with Claude?
While Anthropic consistently states they are working hard to reduce hallucination rates, and models like Claude 3.5 Sonnet are demonstrably better than predecessors, the absence of fully open source, standardized benchmarks and independent validation makes it hard to definitively verify the claims or compare rates across different models objectively. This is crucial for developers relying on Claude for factual accuracy in their applications.
And does the constitutional AI approach fully prevent harmful outputs, or are there nuances there too?
Well, the reliance on constitutional AI for training out harmful outputs is also questioned by some researchers. While it demonstrably reduces overtly harmful content, prior research in AI safety suggests that sometimes these alignment techniques might inadvertently just suppress rather than eliminate underlying biases or stereotypes. They might still propagate in subtle ways, meaning biases might not be entirely gone, just harder to detect.
And given Anthropic's extensive partnerships with major tech companies, are there concerns about how third-party data is handled in those relationships? Because that impacts trust significantly.
Absolutely. Third-party data usage concerns are significant and complex. When Anthropic partners with giants like Google Cloud or Amazon Web Services, questions arise about data flow and usage rights. Anthropic's policies sometimes defer to the partner's policies for data handled on their infrastructure, which can create ambiguity and potentially lack clear, direct accountability mechanisms regarding how customer data submitted via the API might be handled or potentially used by the partner. There's often insufficient public disclosure on whether partners might, for example, use data passing through their systems, even if anonymized, to train their own competing AI models.
Right. That creates a pretty complex data lineage, making it hard to track who's using what data for what purpose. That definitely raises potential privacy and compliance issues for developers building on the platform.
It does, and related to that is the ongoing challenge of potential biases and unequal benefits within the model itself. We touched on the public constitution helping reduce some biases, but is it a solved problem?
Likely not, I guess.
Likely not entirely. The bias benchmark results Anthropic has shared, like the BBQ dataset for Q&A, are sometimes considered outdated given the rapid advancements in AI bias detection and red teaming techniques. Crucially, the company, like most major AI labs, doesn't disclose its full training dataset composition. This lack of transparency means it's hard to independently assess whether the data might inadvertently lead to predisposed advantages for certain demographic groups or perpetuate existing societal biases.
And this becomes particularly high risk in certain applications, right?
Exactly. This risk becomes especially acute when powerful AI models like Claude are piloted or deployed in sensitive government or public sector applications like the reported pilot programs with U.S. Homeland Security agencies, DHS, FEMA, ICE, USCIS. The use of potentially biased AI in areas like immigration, law enforcement, or benefits allocation is categorized as a high risk for discrimination under regulatory frameworks like the EU AI Act.
So it seems, even with the sophisticated constitutional AI approach and genuinely good intentions, there are still fundamental critiques about its overall transparency, the potential for lingering biases, and maybe how well a fixed constitution can handle novel or highly nuanced ethical dilemmas. It's not a silver bullet, it seems, but an important step on a longer journey.
That's a very fair summary. Despite its innovation and positive impact on safety, constitutional AI as a framework does face critiques. Some worry it might inadvertently suppress diverse viewpoints or minority opinions by enforcing a specific set of universal ethical values, which might not be truly universal. Its potentially static nature constitutions aren't updated daily, may struggle to adapt quickly to evolving societal norms or the complex nuances of translating abstract ethical principles into concrete algorithmic behavior. This could risk subtly perpetuating biases embedded within its fixed framework. Furthermore, the lack of comprehensive public transparency around the full constitution used in production models and clear public accountability mechanisms can undermine its ability to provide truly nuanced ethical guidance for complex, real-world dilemmas, particularly when the stakes are high and trade-offs are involved.
It's a complex challenge with no easy answers. Given these identified threats, challenges, and critiques, what proposed mitigation strategies and broader governance frameworks are being discussed globally to try and address them? What should companies like Anthropic and, by extension, developers like us using their tools be aware of on the horizon?
There are several important frameworks emerging. One really prominent one, especially in the U.S. context, is the NIST AI Risk Management Framework, AIRMF. It provides a structured, voluntary approach for organizations to identify, assess, manage, and measure AI risks throughout the lifecycle.
How does the NIST framework break things down?
It organizes governance activities into 4 key functions: govern, map, manage, and measure. Applying this to a company like Anthropic, and by extension to developers considering using their tools responsibly. Under govern, there's a clear need for robust accountability structures, transparent communication, and explicit policies regarding things like third-party data use, rather than just deferring responsibility. Establishing a culture of risk management is key. Under MAP, organizations need to understand the context, identify potential risks and benefits, and appropriately disclose and align their AI trust and safety objectives, especially when working with partners. For Manage, the framework stresses prioritizing risks, planning and implementing risk treatment strategies, addressing harmful usage, automation risks, hallucinations, biases, etc., and rigorously managing risks associated with third-party tools or data sources. This crucially includes having a mechanism to supersede, disengage, or deactivate an AI system if it starts performing inconsistently or unsafely. And finally, under measure, there's a need for continuous evaluation using updated, preferably open-sourced frameworks and metrics, things like Q2 scores or factual grounding BLEU for hallucination, statistical parity, or intersectional analysis for bias. Organizations should also implement robust mechanisms for tracking risks over time, maybe through things like an external red teaming network, similar to what OpenAI has, or a public bug bounty program, and actively gather user feedback on whether the measurements are actually effective. This whole framework aims to bake responsible practices into the very fabric of AI development and deployment.
That's a very comprehensive, structured approach from NIST. What about the EU AI Act? That's legally binding and said to be quite influential globally. How might Claude's capabilities or applications be viewed under that legislation?
The EU AI Act is indeed very significant, and it categorizes AI systems by risk level, imposing different requirements based on that level. It's a useful lens to analyze a powerful, general-purpose model like Claude.
So how would Claude fit into those risk categories?
Well, some applications might fall into limited risk. For example, using Claude for automating AI fine-tuning if there's human validation before deployment, or the mere potential for hallucinations in a low-stakes context. Transparency obligations, like disclosing that content is AI-generated, apply here.
Okay. What about higher risk categories?
Several aspects could push Claude or its applications into the high-risk category, which comes with much stricter requirements. This could include the automation of AI fine-tuning if it leads to auto-deployment without human validation. Also, issues around lack of transparency, particularly regarding training data and potential data memorization, could be seen as high risk. The use of AI for harmful content removal, like constitutional AI aims to do, can actually fall into high risk under the EU AI Act due to complex implications for freedom of expression and the risk of over-censoring legitimate content. And critically, as we discussed, the use of AI like Claude in sensitive areas like employment, access to essential services, or law enforcement is explicitly designated as high risk due to the potential for discrimination.
And are there unacceptable risks, too?
Yes, the Act defines certain unacceptable risks where AI use is banned outright, like social scoring by governments or manipulative AI exploiting vulnerabilities. While Claude itself isn't designed for those, its misuse could potentially fall into such categories if deployed with harmful intent.
So to operate smoothly under regulations like the EU AI Act, companies like Anthropic and developers using their tools in those high-risk areas would need really robust risk management, significant transparency in development and data handling, and clear accountability mechanisms.
Absolutely. Compliance will require demonstrating these things rigorously. This is precisely why understanding the principles promoted by resources like the AI Coach by Anil Nathu, focusing on responsible development, testing, and deployment, is becoming increasingly crucial, especially if your projects touch upon any of these potentially higher-risk application areas.
Okay, those are the challenges and the emerging regulatory frameworks. Zooming in on concrete actions, what are the 3 key mitigation strategies that researchers propose to specifically address some of the fundamental issues like transparency, hallucinations, and bias?
Based on the research paper analyzing Anthropic, 3 key actionable strategies stand out. First, a strong recommendation to enhance transparency, especially in privacy policies.
How specific?
This means practical steps like minimizing data retention periods, implementing default opt-out mechanisms for data collection used for model improvement rather than opt-in, and providing concise, layered, easily understandable summaries of privacy practices, not just long legal documents. For evaluation, they suggest tracking usability metrics. How many clicks does it take a user to access the policy? How long does it take them to find specific information? Maybe even running comprehension surveys to ensure users genuinely understand what they're agreeing to. It's about building real user trust through clarity.
Okay, better transparency is number one. What's the second key strategy?
Second, the need to establish and use rigorous, standardized benchmarks for measuring hallucination and bias.
Measuring them more effectively.
Yes. Using robust, validated metrics like Q2 scores and factual grounding BLEU scores for hallucination, and metrics like statistical parity, measures of group diversity representation, and extra annotations for bias tested against diverse, challenging datasets like HalloEvil or BBQ. Importantly, the paper stresses that these benchmark datasets should not be used directly for pre-training or fine-tuning the models, as that would invalidate them as independent tests. Maintaining benchmark integrity is key. Private leaderboards comparing internal model variance on these metrics can also help foster healthy competition to improve safety and fairness.
Right. You can't teach to the test if you want the test to be meaningful.
Yeah.
Okay, transparency, better benchmarks. What's the third key mitigation strategy?
Third, the crucial need to develop and implement a comprehensive remediation process, particularly around user data.
Remediation, what does that involve for an AI model?
This primarily means having clear, accessible, and effective mechanisms for users to request the deletion of their data, and, critically, implementing techniques for model unlearning. Model unlearning is the technically challenging process of removing the influence of specific data points from a trained model, ensuring that data can no longer be reconstructed or significantly influence the model's future behavior. This entire remediation process, data deletion and unlearning, needs to be transparent, provide detailed guidance and support to users making requests, and include rigorous internal testing and auditing to verify the effectiveness of the data removal or unlearning procedures. It's fundamentally about giving users genuine agency over their data and ensuring accountability for the vast datasets used to power these immense models.
Transparency, rigorous benchmarking, and robust remediation. Those seem like essential pillars for building trustworthy AI.
They really are, and the AI coach by Anil Nathu constantly underscores that understanding these ethical dimensions and mitigation strategies isn't just an add-on. It's absolutely key to not only building incredibly powerful AI applications, but also deploying them responsibly and in a way that genuinely benefits society.
Wow, that was a comprehensive journey. We've gone from the nuts and bolts of the Claude API setup, explored its really incredible capabilities for coding and vision, navigated through the nuanced best practices and the very real challenges developers face, and finally stepped back to consider the critical landscape of AI governance. I feel like we have a much clearer picture now.
Absolutely. We've covered a lot of ground of the power, the quirks, the potential, and the responsibilities.
So let's try to tie it all together now into a practical, actionable plan for you, our listener.
Yeah.
How can you start confidently integrating Claude Code into your own projects, keeping all this in mind? What's step one?
Step 1. Master the setup and basics. Before anything else, get the foundation right. Create that Anthropic developer account. Add some credits to get started. Remember, it can be cheap initially. And crucially, absolutely secure your API key as an environmental variable.
Don't skip that security step. We walked through the McWindows instructions earlier. It's vital.
It really is non-negotiable. Once that's done, install the Anthropic library using pip. Pip install Anthropic. Then just practice making those first basic API calls for simple text generation. Play around with the different models available, tweak parameters like max tokens and temperature just to get a feel for how Claude responds and how the API works.
Okay, get the basics working securely, then what? Don't try to boil the ocean with the first prompt, right?
Exactly right. Step 2, start small and iterate. Resist the temptation to build your entire magnum opus with one giant, complex prompt. It just doesn't work well. Instead, break down your coding tasks into the smallest feasible, manageable features or modules.
Bite-sized chunks.
Yes. And adopt an iterative workflow religiously. Ask Claude for just that small piece of code. Then immediately test it in your actual development environment. Copy any errors, stack traces, or unexpected behavior right back to Claude for debugging. Refine that small piece through this feedback loop until it's stable and correct before moving on to the next piece. This iterative cycle is crucial for managing complexity and ensuring quality with any LLM, and it's a core tenet of the effective development approach emphasized by AI Coach by Anil Nathu.
Context is always king when working with LLMs, especially for coding. We talked about treating it like a human developer. How do we provide Claude with the best possible brief for our projects?
It truly is king. So step 3, provide rich context and structure. For any non-trivial coding project, take the time to prepare those essential contextual documents. A good readm.md, a changelog.md, maybe contribution.md, or usage.md if applicable. Feed these to Claude early on, perhaps as files using the artifacts approach or custom tools, to keep it aligned with your project's goals, history, and established standards.
Give it the background info and structure the prompts.
Yes. When prompting, use structured formats. Maybe experiment with those XML tags. Anthropic recommends task, context, etc., to make your instructions explicit and easily parsable. And consider starting with a design-first approach for complex features. Ask Claude to help you outline the architecture, the data structures, or the algorithmic flow before you ask it to write the detailed implementation code. This gives Claude a strong blueprint to work from.
Okay, solid basics, iterate, provide context. Once you're comfortable there, what about exploring those more advanced features we discussed, like custom tools and vision?
That's step 4. Leverage advanced features strategically. Don't feel you have to use everything at once, but be aware of the power tools. Explore custom tools via the Claude API for tasks that require interaction with your local environment or external services. Identify repetitive actions or local interactions you want Claude to perform, like reading, writing specific project files, interacting with a local database, maybe even calling another API, and define Python functions with those JSON schemas for them. This gives Claude literal superpowers within your project's context.
And the vision capability.
And definitely experiment with Claude's vision capabilities if it fits your project. If your work involves analyzing visual data charts, graphs, UI mockups, diagrams, scanned documents, use the API to send images and leverage Claude's interpretive power to extract information, generate descriptions, or even translate visual designs into code structures. This can unlock entirely new types of workflows.
Now, given all the challenges we discussed, the potential for imperfect code, the hallucinations, the need for cleanup, maintaining that human-in-the-loop mindset seems absolutely vital throughout this whole process, doesn't it?
It is absolutely non-negotiable. You cannot skip this. Step 5, embrace the human-in-the-loop mindset. Always remember that Claude Code, no matter how good it gets, is a powerful assistant, a co-pilot, maybe even a pair programmer, but it is not a fully autonomous developer yet. Expect its output to be, let's reiterate, maybe 60–90% correct on average. Be prepared mentally and in your workflow to review, refine, test, and debug the code it generates.
Your expertise is still central.
Absolutely. And critically, use this process to deepen your own understanding of the underlying technologies and the problem domain. Knowing how to solve a problem yourself, or at least how to evaluate a proposed solution, will enable you to guide Claude much more effectively, ask better questions, spot subtle errors, and ultimately achieve better results in fewer iterations. Your expertise is the guiding force, Claude is the accelerator.
That's a great way to put it. Finally, thinking about the bigger picture, stepping outside the code editor for a moment.
Right. That's step 6. Stay informed on responsible AI. Make a conscious effort to stay aware of the ongoing, rapidly evolving discussions around AI governance, data privacy, algorithmic bias, and ethical AI development. Understand the concepts behind Anthropic's constitutional AI and its implications, both positive and negative, for how Claude behaves.
And the broader regulatory landscape.
Yeah, try to familiarize yourself, at least at a high level, with frameworks like the NIST AI Risk Management Framework or the principles behind regulations like the EU AI Act. Understanding this broader context will help you make more informed decisions about how and where to deploy AI responsibly, especially if your projects involve sensitive user data, operate in regulated industries, or have the potential for significant societal impact.
So, master basics, iterate, give context, use advanced tools wisely, keep humans in charge, and stay informed on responsibility.
Exactly. By following these steps, you'll be well on your way to leveraging the incredible power of Claude Code effectively, efficiently, and most importantly, responsibly, which is a core part of the whole AI coach by Anil Nathu philosophy. #outro.
Well, we have certainly journeyed far today. We started with the technical setup of the Claude API, explored its really incredible capabilities in coding assistance and vision analysis, navigated through the nuanced best practices and those very real-world challenges, and all the way through to the critical, bigger picture considerations of AI governance and ethics.
It's been quite the duck dive. You should now have a much more comprehensive understanding of Claude Code's power, its practical applications in your own projects, and the best practices for leveraging it effectively.
We've seen how tools like Claude Code can genuinely accelerate development in ways that feel almost magical sometimes.
Right. That 5 days instead of 50 example is hard to forget.
Exactly. But we've also underscored the undeniable ongoing importance of human oversight, clear communication and prompting, and maintaining a keen awareness of the larger ethical landscape these tools operate within.
And as we continue to build with and alongside powerful AI like Claude, the crucial question really starts to shift. It's moving away from just asking, can AI do this task?
Yeah, the answer to that is increasingly yes.
Right. The more important question becomes, how can we as developers, designers, thinkers, best collaborate with AI to build a future that is not only incredibly innovative, but also robust, transparent, fair, and truly beneficial for everyone?
That's the real challenge ahead. The journey of learning, adapting, and discovering how to best work with these tools is continuous, and it's happening right now.
It is. And your role as someone engaging with this technology in shaping that future is more important than ever. Every choice we make in how we build and deploy these systems matters.
A perfect thought to end on. Thank you for joining us today. Visit the AI Coach website for more AI insights.